everyone, welcome to today's lesson. Today's lesson we are going to deal with stationary points, and the first thing we are going to learn what you call stationary points. We can say stationary points, they are actually the turning points of the curves. So if you look at the board, I have drawn quite a number of graphs, and each graph, for example this one, it is turning at this point. This is a stationary point. It's actually a turning point of this curve. If you look at this, it is turning at this point, so this is a stationary point. It is turning at this point, so we call it a stationary point. So if you look at this, this is a turning point, so it is turning like that. So if you look at this, this is a curve, it is turning at this point. So that is what you call a stationary point. So at this point, it's good to note that the stationary point, the gradient of these curves, they are equal to 0. So if you find dy dx here is going to be equal to the gradient function, which is going to be 0. The same thing will happen here. The gradient must be 0. Here, the gradient must be 0. The gradient must be 0. So if you look at this curve very clearly, you can see that if you find the gradient on this side, it's going to be a negative. If you find the gradient here, it's going to be 0. If you find the gradient here, it is going to be a positive. And such a curve, such a turning point, we call it minimum. We call it minimum turning point. Look at this. If you look at the gradient on this side, the gradient must be 0. The gradient at this point, it will be 0 because it's a turning. This gradient is, the gradient here must be positive. The gradient at this point must be 0. And the gradient on this side, it must be negative. And in such a case where we have the gradient this side positive, 0, negative, then we must say that this is a maximum turning point. So if you look at this, the third curve, we have the gradient. If you look at the gradient on this side, it is going to be positive. It's going to be the gradient which is going to be positive. Here the gradient is 0, and here the gradient is still positive. And this is a turning point which we call a point. This is a point of inflection. The same thing here. If you find the gradient on this side, the gradient is going to be a negative. The gradient here is going to be 0, and the gradient here is going to be still negative. And we call this point, still we call it a point of inflection. So it's important to know that all these, they are the turning points. It's only that this is a minimum turning point, this is a maximum turning point. These two, they are points of inflection. So we are going to do an example on how to get the turning points. So we are going to look at example. Find the stationary point on the curve y is equal to x cubed minus 3x plus 2, and state the nature of the turning point. The turning point. That is what we are going to look at. So we have the curve y is equal to x cubed minus 3x plus 2. So the first thing that we are going to do is to get the gradient function. Then we equate to 0 because we are looking at the stationary point. So I will get dy dx. It's going to be 3x squared minus 3. Because I differentiate this to get this, I equate this one to 0. And this one, 3x squared is going to be 3. You take 3 to the other side, and x squared is going to be 1. And x is going to be either positive or plus or negative 1. So let me find the values of y. When x is equal to 1, the value of y is going to be 1 cubed minus 3 multiplied by 1 plus 2. So the value of y is going to be equal to 0. So the point is going to be 1, 0. And when x is going to be negative 1, the value of y, it is going to be negative 1 cubed, then minus 3 into negative 1 plus 2. So the value of y is going to be, this is negative 1 plus 3 plus 2. And this one is going to be equal to 4. So the point here, it is going to be negative 1 and 4. So these are the two stationary points. This is the first stationary point. This is the second stationary point. I want to do the second part of it. We want to see the nature of these turning points because we have identified the stationary points. This is a stationary point and this one is another stationary point in form of coordinates. So how do we get the nature? The nature of the turning point. The turning point. So if I had the dy dx as 3 x squared minus 3, this is the gradient function at the turning point. And you remember the stationary point, I still have them as 1, 0 and another one as negative 1, 4. These are the stationary point. So if I need to know the nature of this stationary point, I will need to get the second derivative of this one. So I derive it I get another derivative, so it's going to be d squared y over dx squared. So that's a derivative, that's a second derivative. So I will derive this one, I will differentiate this one. So it's going to be 6x, yes, it will be 6x. So if I need to get the nature of this point 1, 0, I will say it's going to be 6 times the value of x is 1. So this is going to be 6. And if I get a positive number, like now I'm getting here as 6, it's a positive number, then I should conclude that this point 1, 0, it is a minimum. It is a minimum turning point. I should conclude it that it is a minimum turning point because it is a positive. So the other one for negative 1, 4, you can see d squared y over dx squared. I got 6x, so I substitute with negative, so it's going to be 6 times negative 1. This is going to be negative 6. If I get a negative, then I should say that this one is a maximum turning point. Maximum turning point. So I have identified the minimum and the maximum turning point. So I have seen what I've done is I have gone for the second derivative. Then on the second derivative, now the first point is this one. I substitute 1 here, I get positive 6. If the answer is positive 6, then I should conclude that if the gradient is positive 6, I should conclude that it is a minimum turning point. So if I go for the second derivative for the other case, I substitute, I get the negative, then I should conclude that this is a maximum turning point. So I want to do the next example, which is the last example for this case. So we want to find the turning point of y is equal to 1 plus x power 4x power 3, then minus x power 4. Then and state the nature of the turning point. State the nature of the turning point. So the first thing is to get the gradient function dy dx. It's going to be, this is 0. So this is going to be 12x squared minus 4x power 3. That is the gradient function. So after differentiating this, I get it's going to be 12x squared minus 4x power 3. Then I equate this one to 0 because all these turning points, the gradients, there is 0. So I can solve this. I think there's something that is common. I can factor out 4x squared into 3 minus, this is going to be x, is equal to 0, so that I can be able to solve. So you can say 4x squared is going to be 0, so x squared is going to be 0, and x is going to be 0. And also, I can say 3 minus x is going to be equal to 0, and I can say x is going to be 3. So I need to get the value of y. Remember, y was 1 plus 4x cubed minus x power 4. So when x is equal to 0, y is going to be, you substitute 0 here, y is going to be 1. So the turning point is going to be 0, 1. And when x is equal to 3, y is going to be 1 plus 4 times 3 cubed minus 3 power 4. So the value of y is going to be, let me use a calculator. So that's 3 cubed. The value of y is going to be 28. So the turning point is going to be 328. So these are the turning points. I want to know the nature of each of these turning points. So remember, if I want to know the nature, of the turning point, I'd go for the second derivative. Remember, dy dx is equal to 12x squared minus 4x power 3. So if I need to know the nature, I will go for the second derivative. It's going to be d squared y over dx squared is going to be, this is going to be 24x minus 12x cubed. 12x squared, it's not cubed, 12x squared. So for this point 0, 1, if I substitute d squared y over dx squared is going to be, I substitute here, it's going to be 0. So if you substitute and you find that this value is 0, then we can conclude, when it is 0, we can conclude that this one is a point of inflection. We can conclude that this 0, 1, it's a point of inflection. So we go to the second point, which is 328. So remember d squared y over dx squared, I will say is equal to 24x. So I substitute x here, so times 3 minus 12 times 3 squared. And the answer is going to be negative 36. And once I get a negative, I should conclude that this is a maximum. This is a maximum turning point. That is the end of our lesson. I want you to do the next exercise in KLB on the same, so that you can try to practice whatever we have learned today. Have a good day.